All right, so our goal for today is to determine if a quadrilateral is a parallelogram. So in 7.4 we talked about properties of parallelograms. Today we're going to be talking about if a quadrilateral has specific properties, then we can say that it is a parallelogram. Okay? So the first one says that if both pairs of opposite sides of a quadrilateral are congruent, then it is a parallelogram. Which is just the converse of one of the theorems that we talked about the other day. Because we said if a quadrilateral is a parallelogram, then the opposite sides are congruent. So if I'm given this kind of a diagram, so if you're given that, then, oops, I forgot this one. There we go. Then we know that this is a parallelogram. So what you can then add on to this diagram is that these sides are parallel and these are parallel. Remember, those arrows mean that they are parallel, or the dash means that they're congruent or have the same length. Okay? And we can then state that this figure ABCD is a parallelogram. If both pairs of opposite angles of a quadrilateral are congruent, so we're given that A is congruent to C, and we're given that angle B is congruent to angle D, like this. Okay, so if both pairs of opposite angles of a quadrilateral are congruent, then we know that this must be a parallelogram. Just like this is the converse of the one we spoke about the other day that says that if a figure is a parallelogram, then the opposite angles are going to be congruent. So we know that figure ABCD is a parallelogram. All right, this next one says that if the diagonals of a quadrilateral bisect each other, so if I take D and connect it to B, there's one of my diagonals. If I connect A with C, that's another one of my diagonals. And if I say that this diagonal is being cut in half, and this diagonal is being cut in half, so let me make sure I... There we go. So if the diagonals of a quadrilateral bisect each other, this one's being bisected, this one's being bisected, they're both being cut in half, then it is a parallelogram. Meaning we know that these segments are parallel and these segments are parallel, and that figure ABCD is a parallelogram. Okay. Theorem 8. All right, so Theorem 8 says that if one pair of opposite sides of a quadrilateral Now this one's a new one. This one we did not talk about the other day. But if one pair of opposite sides of a quadrilateral is both parallel and congruent, then it is a parallelogram. Alright, so if we have that AB is congruent to DC, okay, and if I also know that AB is parallel to DC, so if this is what you have labeled, then we're able to add in that these sides must also be parallel. Right, because we'll know that figure ABCD is a parallelogram. All right, flipping that page. We're going to actually use these theorems. Okay. And it says, for what value of x must MLPN be a parallelogram? State the theorem that you use. So we want to make it so that this is a parallelogram. What would we need to know in order for this to be a parallelogram based on what's marked? So what do you see that's marked in this first diagram here? Or what do you see that's drawn in? Diagonals. Okay, so let's look. Which theorem talks about diagonals? Number 7. So right away, I know that this must be coming from theorem number 7. So I'm going to write that down because that's the only one that has anything to do with diagonals. Are we okay so far? All right, so then what else do we need to know about that theorem 7? What does it say? What about those diagonals do we have to know in order for it to be a parallelogram? The diagonals have to do what? Bisect each other. Okay, so I have to have this diagonal that's being cut in half and the other diagonal that's being cut in half. So let's put those marks on there. This diagonal is being cut in half, so these are congruent. Oops, there we go. And this diagonal is being cut in half, so these are congruent. You have two things you could do here. You could set 2y minus 7 equal to y plus 2. Or you could set up 3x equals y. Which one's going to help you more? Yes. Why does it help you more if you set up 2y minus 7 equals y plus 2? Because then you're only dealing in one variable and you can get y alone. Yeah, you don't have to worry about substitution or elimination or solving systems there. Okay? So we have to work at getting y alone. So subtract y on both sides. Add 7 on both sides. And we have y alone. But it wants to know for what value of x must it be for it to be a parallelogram. So now that we have y is 9, we know that this segment here is 9, because I can plug that in. I know this is 9 plus 2, which is 11. I know this is 2 times 9, which is 18. 18 minus 7 is 11. What does 3x have to be? 3x has to also be 9 because it's marked congruent to that segment. So now I can actually take and say 3x has to equal 9, divide by 3 on both sides, and x must be 3. That's what the question was asking for. What would x have to be? So if x is 3, then yes, it's a parallelogram. So far, so good? All right, let's look at the next one. It says find the value of A and C for which PQRS must be a parallelogram. State the theorem that we use. This one is giving us angles and sides. So let's figure out which theorem we're going to use here. It gives us angles and sides. But one thing to notice is it only gives us one set of angles and one set of sides. Okay? Do we have both pairs of opposite sides congruent? Did we have both sides or all four sides labeled? No, so we can't use that one. Do we have all four angles labeled there? No, we only were dealing with two. We can't use that one. We didn't have diagonal, so I'm not even going to look at that one. So that kind of leaves us with theorem 8. We did have one pair of opposite sides, and we have to show that then one pair of opposite sides are congruent and parallel, or parallel and congruent. Okay, so we have to use theorem 8 here. So one pair of opposite sides
Good morning, teachers. Please pardon the interruption. Please send down all students, grades 9 through 12, last name A, last name B. Thank you.
Okay. So one pair of opposite sides, both parallel and congruent. Okay. So I can see then that these must then be congruent, but I also have to show that they are parallel. So what do I know then if these are going to be parallel and congruent? The sides have to be set equal to each other. So that's one of your setups. What do you know, though, about these angles? What would make these lines parallel? What would you have to know about these angles? They would have to add up to 180. They would have to be supplementary because they're the same side interior angles. These are same side interior. This is how we usually look at a transversal. But those are same side interior. If those add up to 180, then we know that these lines here must be parallel. Do you see that? So we have to use those rules about two parallel lines in a transversal here. So we know that these are, so we'll make this note, SSI must be supplementary. Okay. So then that tells us we know that we said the sides have to be congruent, so we know 3c minus 3 has to equal c plus 1. And we know that these angles have to add to 180. So a plus 40 plus a has to equal 180. And then we have to solve for both a and c. So add 3. Subtract c. 2c equals 4. Divide by 2 on both sides. C equals 2. This one you're going to have to combine like terms because it's on one side. So 2a plus 40 equals 180. Subtract 40 on both sides. 2a equals 140. Divide both sides by 2. A equals 70. We found A and C, but let's make sure that they make sense. So if I plug in C over here, I have 3 times 2 is 6. 6 minus 3 is 3 for that side. 2 plus 1, C is 2, so 2 plus 1 is 3. 3 for that side. Are those sides congruent? Yeah, 3 is equal to 3, so those sides are congruent. Let's check the angles. 70 plus 40 would be 110 degrees there. This would be 70 degrees here. Wait a minute. Are those supposed to be the same? No, what were they supposed to be? Supplementary. They're supposed to be adding up to 180. Does 110 and 70 add to 180? Yeah, so we're on the right track. Done. Okay. For number 3, it just says, is it a parallelogram? State the theorem that we use. So, let's see. This one has to deal with angles. So let's look and see which one tells us if it's a parallelogram that has to deal with angles. So this one starts with segments marked congruent. This one starts with angles marked congruent. So I would look at this one. And what does it say? It says if both pairs of opposite angles of a quadrilateral are congruent. So if opposites are congruent, we'll know it's a parallelogram. Let's look and see if this matches. Are opposite angles congruent? Yes. How about these opposite angles? Are they congruent? Some people are shaking their head yes, and some are shaking them no.
Yeah, they are.
Why?
Because they have to have it. Because they're ultimately.
They both add up to what the first angle is minus 180.
How do you know that? How do you know they add up to whatever the first angle is minus 180? We don't know anything about this one here, other than that those are the same. But how can you look at this and know that this angle here and this angle are the same?
Because it's one angle and the other angle on the other side, and there's another angle on the.
They're made up of two of the exact same angles. A 2 dash and a 3 dash, and a 2 dash and a 3 dash. Whatever these two numbers are that add together, whatever these two numbers are that add together, they're the exact same two numbers. They have to add to the same thing. Is that okay, that idea? So this and this, these are congruent. Okay, because they're both made up of a double arc and a triple arc. Double arc and a triple arc. Does that make sense? So these ones are congruent. They're made up of the same two angles. Okay. So if those are also congruent, these are congruent, we can say that yes, it's a parallelogram. And what was that theorem number? 6. Okay. This one has sides labeled congruent. So let's look at what theorem has the sides labeled. The very first one, theorem 5. Do the opposite sides, if the opposite sides are congruent, then it's a parallelogram. Do we have opposite sides that are congruent here? No. We have consecutive sides that are congruent. So this one's a no. It's not opposite sides. Do we remember what the shape is called if you have two pairs of congruent sides that are next to each other or adjacent? What is it? A kite. So this one's no because it's a kite. Okay, this one has only one set of opposite sides labeled. So let's look and see if the theorem only talks about one set of opposite sides. Theorem 8 talks about just one set of opposite sides, and it says that they have to be parallel and congruent. So let's see if the opposite sides that we have labeled are parallel and congruent. Are these lines parallel? Yes, that's what those arrows mean. Are they congruent? How do you know they're congruent? They're both marked X. If they're both marked X, that means they have the same length, meaning that they are congruent. So this is yes, and that's from Theorem 8. All right. Last diagram here. And it has diagonals labeled. So let's look at the diagonal theorem. And it says that if the diagonals of a quadrilateral bisect each other, then it's a parallelogram. So if we have this diagonal that's being cut in half and this diagonal that's being cut in half, it's a parallelogram. So let's see if this is what we have labeled in that diagram. Is that what we have labeled? No. If you're looking at this diagonal, it is not being cut in half. Or at least we don't know if it's being cut in half. So this one is no. So let's take a look at the assignment, and then you guys can get started on it. So we're looking at the assignment. It says find the values of the variables for which A, B, C, and D must be a parallelogram. So all of these first ones have to do with diagonals. So what do you guys know about the diagonals of a parallelogram? Mark them, set them up. Okay? Once you get to 4 and 5, those ones are dealing with side lengths. Okay, so you're going to compare these to the diagrams just like what we did on this example here. We have to figure out what theorem does it go along with, what do we know about them, and then do the algebraic setup. Okie dokie. 10, 11, and 12 are just like what we did on example 3 here. Based on the labels, can you determine if it's a parallelogram? There is a cookie cutter proof here where you just have to fill in some blanks. And then some more algebraic setups. Numbers 17 through 22 are review problems. Okay, so they're from previous sections. So, you guys have the rest of the time to work today.